In this video, we look at right triangle trigonometry. Now, when we first defined the trigonometric functions, we did so in terms of the unit circle. Now, if you remember, when we were doing sine and cosine of two angles in particular, pi over 3 and pi over 6, we found those values by forming right triangles within this unit circle, where the radius was the hypotenuse, as we're shown here. Now, this leads to a second way of defining trigonometric functions in terms of right triangles. We will use this right triangle here to see if we can find a natural definition. So here we have xy. We call x the side that is adjacent to the angle, and y is the side that is opposite of the angle. From here, or remember from unit circle, cosine of t was equal to x, and sine of t was equal to y. Well, we can rewrite x as x over 1, and we can rewrite y as y over 1. In other words, the cosine function is the ratio of the side that is adjacent to the angle to the hypotenuse, and sine is the ratio of the side opposite of the angle to the hypotenuse. This idea naturally extends to any right triangle that has a hypotenuse of any length. So we're going to look at this triangle here. Right, here's our angle t. This is the adjacent side, the outside, and the hypotenuse. Sine of t is defined to be the opposite over the hypotenuse. Cosine of t is defined to be the adjacent over the hypotenuse. And remember, tangent was sine over cosine, and so we get opposite over adjacent. Now there is a mnemonic to help us remember this. The mnemonic is called SOHCAHTOA. So we have sine, opposite, hypotenuse. So that says sine is opposite over hypotenuse. Cosine, adjacent, hypotenuse. Cosine is adjacent over hypotenuse. Tangent, opposite, adjacent. Tangent is opposite over adjacent. So we have a triangle here, and we wish to find the value of the 6 trigonometric functions of alpha. Right? So sine of alpha. So sine is opposite over hypotenuse. So it's 8 over 17. Cosine is adjacent over hypotenuse. So it's 15 over 17. Tangent is opposite over adjacent, 8 over 15. Then we can write the cosecant is 1 over sine, 17 over 8. Secant is 1 over cosine, so 17 over 15. And cotangent is 1 over tangent, so 15 over 8. We now look at some cofunction identities, and all of these identities come directly from this figure. Right, for instance, sine of alpha, right? If we have this here, let's call this AOH. Then we know that sine of alpha is A over O. But look at cosine of beta. I'm sorry, sine of alpha is O over H. I really messed that one up. O over H. Right, but look at cosine of beta, right? The angle that is adjacent to beta here is O. Now, we know that the sum of all the angles has to be 180. So this is pi over 2. So we must have alpha plus beta being pi over 2. So cosine of t, sine pi over 2 minus t. Right? In terms of here, the cosine of beta, beta has to be alpha minus pi over 2. I'm sorry, it has to be pi over 2 minus alpha. Then the sine of t would be cosine of pi over 2 minus t. Tangent of t is cotangent pi over 2 minus t. Then cotangent would be tangent pi over 2 minus t. Secant is cosecant of pi over 2 minus t. And finally, cosecant is the secant of pi over 2 minus t. So all the cofunctions. So if you have cosine of t, that is also sine of pi over 2 minus t. Right? Tangent, cotangent, secant, cosecant. So to find the height of a tree, a person walks to a point that is 30 feet from the base of the tree. He measures an angle of 57 degrees between a line of sight to the top of the tree and the ground. Find the height of the tree. Let's see. That's a very badly drawn tree, but let's say that is our tree. We know that the person, let's say the person's standing right here. Right? And that is 30 feet away from the tree. The angle from the top of the tree is 57 degrees. So what do we have? We have angle that is adjacent. We do not know the hypotenuse. In fact, that is what we're looking for. I'm sorry, that's not what we're looking for. We're looking for this measure right here. Right? This is our height. That is the measure we're looking for. That is opposite. So what function gives us ratio of opposite and adjacent? Well, tangent, right? Tangent of 57 degrees has to equal the height over 30 feet. So height is 30 feet times the tangent of 57 degrees, and we find that is about 46.2 feet. So the tree is about 46.2 feet high. Right? And a lot of application problems are like this. You can solve them by forming a right triangle and then using the appropriate trigonometric function. That is all there is to the introduction of right triangle trigonometry. Most of it was already done with unit circle. Here we just showed how we can define the trig functions in terms of the sides of a right triangle.